Very good afternoon to all of you. So once again, I welcome you all for this today's second lecture of our subject industrial hydraulics and pneumatic. Okay, so in the first lecture, today's first lecture, we have discussed some ISO standard symbols which are used in hydraulic and pneumatic system or circuit. Now, now I'm going to start a new point, that is pneumatic actuator. But before discussing this point, let's have that remaining symbols. That is, I think regarding flow control valve, some symbols are remaining. Okay, so I will share that video. Okay, which we were discussing in the morning. Okay. Just a minute.
In this video, I explain the various symbols used in hydraulics and the pneumatic systems. And these symbols are the symbol for a flow control valve. Then after I explain the symbol.
Whether my video is visible at your end, my audio or that video's voice. Okay. Whether everything is okay at your end, just confirm. Tell me. Okay.
For a various pipelines, then accumulators, then intensifiers, and the different types of the heat exchangers. So first, I explain the symbol of flow control valve. So here on this screen you see that is a different symbol is used for the flow control valve. Okay, so all these symbols are for the flow control valves. So these indicate something different thing. Every symbol is indicate some different. So here I explain you one by one. Now the first is the fixed restrictions flow control valve. Means in this fixed restriction flow control valve we are not able to adjust the flow control. That is a fixed amount of the flow rate is passed from the flow control valve. For that, symbol is like this. First you need to draw two cow lines, and from that the one line is going, means the fluid is flowing from these cow portions. Next one is the variable restrictions flow control valve. Means in that valve we are able to adjust the flow rate. Okay, so earlier we studied in different symbols that the speed is adjustable. At that time what we doing, we are draw the one line at the 45 degree. Okay, so similarly when the something is adjustables, variables, or the speed is changeable, at that time we need to draw the one arrow line at the 45 degree in a existing symbol, means in a fixed restriction symbols. So we draw one line here. This indicate the variable flow control is possible. Next is the variable flow control valve with reverse free flow. So here what word is used, that is the same thing. Okay, variable restriction flow control valve means that is a variable FCV is written instance of the flow control valve. So we take this symbol and in this symbol we add the reverse free flow. Okay, so how we draw the reverse free flow? In earlier few symbol we studied that the reverse free flow is possible by providing the check valve. Okay, now here we take the same symbol of this variable restricted flow control valve. In that we provide the one check valve, and this check valve is connected with this inlet and outlet of the flow control valve. So this is the symbol of variable FC with reverse free flow. Next is the pressure compensated variable FCV with reverse free flow. So this name is same, that is the variable FCV with reverse free flow. So we need to take this symbol of the variable FCV with reverse free flow. So we take directly these symbols. Now new thing is that the pressure compensate. So we draw the one vertical arrow line here. This is indicate this FCV is pressure compensate. Next one is the temperature and pressure compensate FCV with reverse free flow. So for that we take this symbol same for the pressure compensate variable frequency valve. So we directly take these symbols, okay, and these
whatever the symbols of this flow control or any controls are there, no? So all these symbols are common to both hydraulic system or circuit as well as pneumatic system. Okay, so please remember this point.
upper arrow is indicate the pressure compensate. For the temperature compensate, we draw the one downward arrow. Okay. Next is the flow meter. Flow meter is generally measured the amount of the flow rate. Okay. For that symbols, we take this symbol of the fixed restricted flow control valve. Okay. So first you need to draw the symbol of fixed restriction flow control valve, and these two curved lines are covered by the one circles. Okay. So this symbol is converted into the flow meter. Okay. So in this symbol you draw one circle here, then it is converted into the flow meters. Now before moving it, I request to like the video and subscribe my flexible. For that flexible connection means that is next symbol is for the pipeline connection, OHP subject as well as the another subject of the mechanical engineering. Now next symbol is for the pipeline connections. So first pipe is the flexible pipeline, means that is a hose connection. The pipeline is flexible. For that flexible connection we need to do one curve line. Okay, so we know that the flexible pipe is bent in any way. Okay, so here the pipe is bent on this shape. Okay. Next one is the junction of pipelines, means junction of pipeline is like as the road junctions. Okay, generally the road junction is take where the four way is there. Okay, the similar way that is not in a pipeline, that is only four. If 2 or 3 is also possible. Okay, so here suppose from this pipeline oil is enter, and this oil is supplied in these three directions. Okay, it is called as the junctions of the pipelines. Now next one is the jump. Jump means two pipelines not connected but cross over each other, means two pipes are not connected like is the junction, but they are here the one pipe is there, and from the one pipe over or below one another pipe is passed. Okay, so we draw these curve lines, so they are not connected, means from this pipe one fluid is flowing and from this pipe some different fluid is flowing. Okay, in a different directions. Here what, that is only one fluid is enter and it is divided in the number of three directions. Okay, or it is also possible that fluid is coming from the three pipe, it is mixed and supplied to one, means all the pipes are connected, means here four pipe is considered, but here only two pipe, they are jumped from each others. Next symbol is for the FRL unit. FRL unit that is used in a pneumatic system. F means filter, R means regulators, and L means lubricators. So all the three components have seen different functions. So for FRL unit the two symbol is provided. One is the simplified symbol and second one is the detailed symbols. Okay, so first we understand the detailed symbol. So this is the symbol for the filter. Okay, that is a one square at the 45 dash line and one horizontal line. This is the filter. R means regulator. Regulator means it is the pressure regulator. So we draw the symbol of the pressure relief valve. Okay, and the L means lubricator. So this is the symbol of lubricators. Now in a simplified symbol, all three symbols are connected and one simple symbol are made. One rectangle is there, inside one circle one arrow line, and the one another arrow line at 45 degrees. So this is the combined symbol, or it is called as the simplified symbol of the FRL unit. Next one is the shuttle valve. So for the shuttle valve, here you see that is a three different valve is provided, or a three different pipe, that is a pipe, B pipe and the C pipe. On A pipe the check valve is provided, here the C pipe and this B pipe, it is called as the shuttle valve. Next one is the quick exhaust valve, means it is used to exhaust the fluid quickly, it is called as the quick exhaust valve. So it is the pressurized pipe P, means the pressurized fluid is coming. This is the A pipe connection, and here the check valve is provided and E is written, means exhaust is going from this side. So it is the quick exhaust valve. Next one is the twin pressure valve, or it is also called as the A&D valve. Okay, so here you see that is a one rectangle, two pipe A, B, and third one pipe is the C. Another is the time delay valve. So this is the symbol of the flow. one circle, one arrow line, and the one another arrow line at 45 degrees. So this is the combined symbol, or it is called as the simplified symbol of the FRL unit. Next one is the shuttle valve. So for the shuttle valve, here you see that is a 3 different valve is provided, or a 3 different pipe, that is A pipe, B pipe and the C pipe. On A pipe the check valve is provided, here the C pipe and this B pipe. It is called as the shuttle valve. Next one is the quick exhaust valve. Means it is used to exhaust the fluid quickly. It is called as the quick exhaust valve. So it is the pressurized pipe P, means the pressurized fluid is coming. This is the A pipe connection, and here the check valve is provided and E is written, means exhaust is going from this side. So it is the quick exhaust valve. Next one is the twin pressure valve, or it is also called as the A and D valve. Okay. So here you see that is a one rectangle, 2 pipe A, B, and third one pipe is the C. Another is the time delay valve. So this is the symbol of the flow control valve. So time delay is possible by controlling the flow rate. Sometimes we supply the flow of the air, or sometimes we not supply the air. Okay, so this way we are able to adjust. So at the outlet, the another two symbol is connected for this pressure measurement device and this directional control valve with that. That's why we are able to do the change in the time delay. Next is the cam operated FCV, means flow control valve is operated by using the cam mechanism. So here you see this is the symbol of flow control valve that we already studied. Okay, this cow line, this is a variable FCV, and this is the reverse flow check valve. So this is connected with the directional control valve, and this directional control valve is operated by the cam. Okay, so here you see that is a two positions of the directional control valve. This is one position, this is second positions, and this circular component is for the cam operated that we already study in a directional control valve. Okay, next one is for the accumulators. So accumulator is different type. One is the dead weight accumulators. So first thing is the common, when you draw the symbol of accumulator, you draw this like of the vessel. Okay, one straight line, then two half circle on each side. Okay, and one horizontal line, vertical line here. Okay, now in this accumulators we provide the dead weight, means we need to put some weight on this platform. If it is the spring loaded accumulator, then we need to throw the one spring on this upper part instance of this weight. And the gas loaded accumulators, so gas is supplied from this pipe and this gas is acting some pressure on the accumulators. Next is the quick disconnect coupling. So coupling is generally used to connect the two shafts. Okay, so this first valve is indicate the coupling are connected, and the second symbol is indicate the coupling are disconnect. Then after that is a symbol of heat exchangers. Heat exchanger first for the heater, and the second one is for the cooler. Heater means it is generally used for the heating the hydraulic oils, and the cooler is used for cooling the hydraulic oil. So generally you know that the heat exchanger is either used for the heating as well as for the cooling of. Okay, so in a heater or any heat exchanger, first you need to draw one square at a 45 degree, one horizontal line is common. Okay, now in which direction you draw this arrow? Okay, in this heater you see that is the arrow is going inside, and in a cooler arrow is going outward. Okay, now when we need to heat the oil, at that time we need to supply the heat energy. So this arrow is indicate that we are supplying some heat energy to the heater, and for the cooler we need to remove the heat from the oil. So this outward arrow is indicate that the heat is removing from the heat exchangers. Okay, next symbol is for the air dryer. So air dryer we draw the one square at the 45 degree, that is a diamond square, and two arrow line inside. This line is indicate input, this line is indicate the output. Same as the muffler. Muffler is used in a pneumatic system to reduce the sound. For a muffler this type of the symbol is used. Next one is the flow divider, means flow coming from the third pipe is divided in a two directional. Okay, so here one FCV is provided and here another FCV is provided, and the flow is written 50-50%. Okay, it is also possible that it is divided in three directions, that is in some pipe 30%, in some pipe 20%, in some pipe 50%. Okay, now more symbol is for the air receiver tank. This is the symbol for the air receiver tank. Next one is the pilot operated check valve, means some oil or a gas is drained from some component, and by using this oil or a gas we operate the check valve. It is called as the pilot operated check valves. So first one is the pilot to open check valve, and second one is the pilot to close check valve. Okay, so this is the open close valve in which this dash line is drawn here. This dash line is indicate the drain or a pilot. Next one is for the intensifier, that is the single acting intensifier and the double acting intensifiers. Okay, in a single acting means on a one side of the piston only the fluid is supplied, that's why only one port is provided. In double acting, on a both side of the piston the fluid is supplied, so here you see that is a two port, port A and the port B. So thank you for watching this video. If you learned and liked the video, subscribe.
Okay, I hope we have covered all the symbols, okay, very nicely manner, and you understood also. Okay, now let us come to our today's main agenda, that is pneumatic cylinder. Okay, okay, wait, just I will share my script, my PPT. Just a minute. Okay. I think screen is visible at your end, no problem. So already in the unit number 1 about the hydraulic system or hydraulic section, we have gone through the first basic element, that is actuator, in the unit number 1. Similar way in this unit also about this pneumatic, we have the pneumatic actuator. Okay, so let us begin with the definition, that is what are or what is meant by this pneumatic actuator. Okay, so pneumatic actuators are the devices, okay, that are used. Okay, pneumatic actuators are the devices that are used for converting hydraulic energy into mechanical energy. Now that hydraulic energy means what? Pressure energy of a air, compressed air, pressure energy of the air, or you can also call it is pneumatic energy, and that is going to converting this pressure energy or pneumatic energy or hydraulic energy of a air into mechanical energy, which is used to perform the useful work. Okay, which is used to perform the work. That is the definition. And again, please, once again, in simple words, I would like to tell that the pressurized air is there, no? So that pressurized air actually it is delivered by the another element, and that another element means what? That is the air compressor. So pressurized air, it will be delivered by the air compressor, and then that pressurized air is supplied to your pneumatic actuator. And in that pneumatic actuator, it will convert that pressure energy of the of air into the mechanical energy. Okay, so again, this mechanical energy, what are the converted no in the pneumatic actuator? So this mechanical energy is used to perform the some useful work. Getting it? So again, in simple words, I can say like that. These pneumatic actuators are the devices which are used by the means of converting the air pressure, which is delivered by the air compressor or the air circuit. Okay, and that is going to that air pressure energy is going to convert it into the mechanical energy. Means what? Which is going to apply force or motion to perform useful work. Getting it? Now, like our hydraulic actuators, okay. Here also for pneumatic actuators also, uh, these actuators are produces linear motion, rotary motion, or oscillating motion. Okay, as like our hydraulic actuator, these pneumatic actuators also produce linear motion, rotary motion, and oscillating motion. Getting it? So depending on that, the pneumatic actuators are divided into two types. Okay. So based on the types of the motion that produced by actuator, this pneumatic actuator, these pneumatic actuators are categorized into two types. Okay. First is a linear actuator. It is also called pneumatic actuators. Sorry, pneumatic cylinder. Okay. Linear actuators. This section, this category also was present in the hydraulic section also, and that time it is called hydraulic cylinder. Here in the pneumatic, it is called linear actuator, or it is also called pneumatic cylinder or air cylinder. And the second is okay, linear actuator means what? Here the actuator is going to produce linear motion, and the second is the rotary actuators, or it is also called as air motors. Here that actuator is going to produce a rotary motion. Okay, so it is called air motor. In the hydraulic, for such a actuator, rotary actuator, it is called hydraulic motor. Okay, and here it is called air motor. Okay, so the first one, that pneumatic cylinder. Okay, so that pneumatic cylinder generate motion in a linear way, means what? In a straight line, for our purpose to perform that useful work. Getting it? The pneumatic actuators, this first type, or linear actuators or the pneumatic cylinders. Okay, they generate motion in a straight line. Okay, to perform the work. And the second one, that air motor. So that the air motors generate rotary output or rotary motion. Okay, for our purpose, once again, to perform useful work or to get useful work. Okay, and here please remember one thing is that, or you can take a note of one line, that the at the outset, no outset, for this pneumatic hydraulic, the construction, working, and the function of hydraulic and pneumatic actuators are very much similar. Okay, please write at top of your notebook or at bottom the working of the construction, working, operation, or functions of hydraulic actuators and pneumatic actuators are very similar to each other. Okay, but generally these pneumatic actuators are of lighter construction and of lesser weight. Okay, please remember this in general point. Pneumatic actuators are of lighter construction and less weight. Okay, so this is because here the fluid medium is there, no, in the pneumatic. It is the air, okay, and that can be used mostly for low or medium pressure application only, no. Okay, so please remember this point. Now these linear actuators, or you can call pneumatic actuators, again further divided into sub category or the subtype. So it's a classification we will discuss. So classification of the air actuator, or sorry, air cylinder or pneumatic cylinder you can call. So here I have mentioned. So please remember, these pneumatic cylinders are devices which are used for converting the air pressure. Okay, that is your pneumatic energy for converting air pressure into linear mechanical force and the motion. For converting air pressure into linear mechanical force and motion, that is called pneumatic cylinder. Getting it? And these pneumatic cylinders are basically used for single purpose application. Now which are that single purpose application? So like clamping, stamping, transferring, branching, or allocating, or ejecting, or metering, or tilting, bending, turning application, and many other applications. Single purpose application, for that purpose pneumatic cylinders are used. Getting it? This pneumatic cylinder. So these pneumatic cylinders are again classified into the subtypes. So the different classification of this cylinders, pneumatic cylinders, I will explain now. Now, firstly, the based on application for which air cylinder I use, no? Okay, based on the application for which air cylinder is used, or air cylinders are used, no? So depending on that, these air cylinders or pneumatic cylinders are classified into three types. One is the light duty air cylinder, second is the medium duty air cylinder, and third one is the heavy duty air cylinder. Okay, so depending on or based on the application for which air cylinders are used, no? So different from that, three types are there. Then based on the cylinder action, okay, or based on the cylinder function, you can also call. So our these air cylinders are classified into basically two types. One is the single acting cylinder, and second is the double acting cylinder. And further again, uh, based on the again other types, here we have the diaphragm cylinder is there, rolling diaphragm cylinder is there, then tandem cylinder. Okay, and then based on the cylinder momentum again. Okay, based on the cylinder momentum, these pneumatic cylinders or the air cylinders are classified into two types. One is the rotary type air cylinder. Okay, these air cylinders are also classified into two types. One is the rotary type air cylinder and non-rotary type air cylinder. This classification, this category has been made based on the cylinder's momentum, and based on the cylinder's design, we have this tandem cylinder, telescopic cylinder, okay, then a cushioned or cushioning end cylinder, okay, or a through a rod cylinder. So that are different types, okay, which are made based on the cylinder's design, okay, and based on the application of the based on the application for which cylinder, for which air cylinder we use, no. So that I have explained, that lightweight, medium duty, heavy duty. Getting it? Okay. So please remember that in hydraulic also, in the hydraulic actuator, we have discussed single acting, double acting, rotary type, okay, non-rotary type cylinder. Okay. Now let us go for the first one, that is a single acting cylinder. Single acting cylinder. So this is schematic diagram of the single acting air cylinder or pneumatic cylinder. Okay, so as the name suggests, single acting, these air cylinders are deliver a force into only one direction. Okay, only one direction. These types of the air cylinder or the pneumatic cylinder deliver a force in a only one direction, and in these types, air only move or pushes the piston in only one direction. Okay, if you consider this schematic diagram,
the air will come from this port, okay, and due to that only this piston will move towards this direction, okay, and due to the spring, okay, this is a spring return type single acting cylinder. So the retraction stroke will happen due to that spring only, okay. So once again I am repeating, in this type of air cylinder, pneumatic cylinder, air only move or pushes the piston in only one direction, and the piston is returned by means of external spring or gravity, okay. So this figure is the spring return type single acting air cylinder, getting it? And in this what are the construction is there? No, it is similar to the hydraulic cylinder which we have seen in the single acting air cylinder, getting it? The same way in the double acting cylinder, I will show. Double acting cylinder, air will come from one port, and due to that air pressure, force is going to apply on the one side of piston, and due to that only piston will move towards the another side. Then during the retraction from that another port, air will come, and due to that pressure of air pressure, it will return to its original position, okay. So that is a double acting cylinder. That means in the double acting air cylinder, air pressure can be applied to either side of the piston, okay. In both the side of the piston, air pressure can be applied, and therefore that pneumatic force is going to apply in both the direction, okay. Please remember the construction working principle or the graphical symbol. Again,
merits of the advantages, disadvantages of the single acting and double acting air cylinders are very much similar to that of our hydraulic cylinder, for which we have discussed in the hydraulic section, getting it? Once again I am repeating the construction, operation, working principle, graphical symbol, everything is similar for this double acting single acting and double acting air cylinder, okay, which is similar, this is similar to that of our hydraulic cylinder, getting it? Just a minute. Again this telescopic cylinder, okay, same thing, same cylinder we have discussed in the pneumatic also. Now telescoping is what? It is a combination of two or more than two cylinder, okay. So you can see here also, here is A means what? This is a first one cylinder, this is a second one B, and this third one. So fluid will come from this fluid supply port, okay. Then it will go inside this E cylinder, okay. Then the fluid will move from this port, and it will enter into this second cylinder, that is B. Then further it will move in the C cylinder, okay. And due to that only, the further this ram or the rod of this cylinder will extend in upward direction, okay. So you can see here, it's a standard symbol. Fluid will take for upward or for lifting, fluid will come from this R, okay, and for exit this port. This symbol is common for both hydraulic cylinder and pneumatic Okay, and please remember this type telescopic cylinder, and it is normally used in our dumper or tipper. Okay, you can see here I have shown the it's a diagram also where it is located. You can see, getting it. Now I will show one small video. Okay.
Pneumatic cylinder is a linear actuator powered by compressed air to supply force on a load. The assembly shown here is the most common type of double-acting pneumatic actuator used in industries. It consists of a piston rod. This rod transfers force of compressed air to the load. Cushioning pistons are assembled with this rod. These pistons prevent any hard shocks at the end of the stroke by enabling the piston to stop slowly and gradually. The piston reciprocates back and forth when there is pressure difference between any of the two sides. A static seal ensures airtight sealing between the piston and rod. Piston guide rings are assembled to prevent metal-to-metal contact of piston and cylinder. Piston seal provides airtight sealing between the cylinder and piston. This whole assembly then goes into a cylindrical bore. This cylinder is generally made up of aluminium or steel. A cylinder cap encloses cylinder chamber in one end, and the cylinder head encloses a chamber from the other end. Cushioning buffers and seals are installed on respective ends. Captive adjustable cushioning screws are installed on each end. These screws enable user to adjust the optimum cushioning at the end of the stroke. This whole assembly is held together with tie rods. These rods also provide compressive and tensile strength to the actuator. Air ports are screwed to the ends through which compressed gas flows in and out. A pneumatic valve is connected to these air ports using pneumatic hoses. The valve shown here is a 5-port 4-way valve. The ports A and B are connected to the cylinder. Port P is connected to the compressed air supply unit. Ports R and S are exhaust ports to which the pneumatic mufflers are attached. Now let's understand how a pneumatic cylinder works. The compressed air is supplied through inlet port P of the valve. The valve directs air to a particular direction, which we can observe in the animation. In this case, the air is directed to port A. This high pressure gas is then transferred to the cap end of cylinder through the pneumatic hose. This creates high pressure in the cap end of cylinder, which therefore pushes the piston towards the head end. This also pushes gas from the head end. This exhaust gas travels through the other hose and reaches the valve. The valve travels through the other.
Please look at that direction or the flow of the air. Okay, and how that due to the pressurized air which is going to enter through that inlet port, and due to that pressure, how the piston is traveling towards that another side. Okay, whether this video is useful to get more knowledge or to visualize the construction of double acting cylinder, whether this is useful, whether it is relevant, please tell me in the chat box. Please reply me whether this animated video is useful to get more knowledge, to visualize the construction or the working or the operation of the cylinder, air cylinder. Okay.
The hose and reaches the valve. The valve directs this gas towards port S and allows it to escape through a pneumatic muffler. The gas muffler helps to reduce any noise produced during exhaust. The process we just observed is the extension stroke of actuator. During the retraction stroke, the valve directs compressed air to the head end of cylinder. This causes the piston to return and air on the other chamber escapes from the exhaust port R. The theoretical force of actuator is the relative pressure on the piston multiplied by effective area of piston on which pressure is exerted. Here, the relative pressure is pressure of supplied air minus the atmospheric pressure. During extension stroke, compressed air can exert pressure on total cross-sectional area of piston. This gives us the expression of theoretical force as relative pressure multiplied by total area of piston. During retraction, the effective area of piston is reduced because the air cannot exert pressure on the area of rod. This gives us the expression of theoretical force as relative pressure multiplied by partial area of piston. Frictional losses on the interface of different surfaces also needs to be considered while designing pneumatic cylinder. The diameter of rod and length of stroke is also a determining factor for capacity of actuator.
Okay. I have one other one. In
This video is brought to you by us, Real
all types
Parts.
of pneumatic
Join the
cylinders are
top 1% of PLC programmers. Learn from the world's best so you can join their rank. Head on over to realpars.com and start learning now. In this video, we're going to talk about pneumatic actuators. We'll look closely at the operation and application of the most common pneumatic actuator, the spring diaphragm linear pneumatic actuator. First of all, let's look at actuators in general. What is an actuator? Simply stated, an actuator is a device that makes something move or operate. Actuators make life easier for us every day, and they are the workhorses of the industry. For example, your dentist uses an actuator to move the chair up and down. There are three typical types of actuators used in industry as defined by their energy source. The typical actuators in the industry include electric, hydraulic, and pneumatic. Okay, let's move on to the focus of our video, pneumatic actuator. A pneumatic actuator converts energy in the form of compressed air into movement. Pneumatic actuators are categorized by their type of motion. They are either linear or rotary. A linear pneumatic actuator can move something in a straight line. For example, a rod is moved in and out of a cylinder in a linear motion by
here I want to make one comment that what are the actuators we are going to learn, we are learning here now. So this actuator normally it is used in the nowadays in industries, okay, because we know that the automations are happening in the industry in a very fast rate, getting it. So their mechatronics parts are used. So in the mechatronics, we know that mechatronics is the combination of the mechanical part as well as the electronic systems. Okay, in that electronic system, a microprocessor, okay, 8085, okay, or the microprocessor 8051. So that are used. Okay, actually there's that are the other parts through which we are getting command to whom, to the sensor, or to the sensor we are getting signal to this actuator. Okay, if from a sensor, if you will get the signal to move or to flow that air in the actuator, then and then only it will move. And once the flow of air will pass through this actuator, then and then only the ram or the piston of that cylinder or actuator is going to move. So actually, please remember that these air cylinders are mostly used in the in the industrial, but up to some limitation. Okay, so if you will have the mechatronics subject in the your final year, I think electric subject is there. If you choose that, Then there also you are going to learn that PLC or SCADA and that microprocessor, microcontroller, sensors and actuator is the one topic is there. So in that actuators, you will have this type of the actuators. Okay, so please remember.
Pneumatic energy source. A rotary pneumatic actuator can make something move in a circular motion. For example, a rod in a rack and pinion drive system is used to produce rotary motion.
This rack and pinion rotary actuator. Actually, this is a type of the pneumatic actuator that pneumatic cylinder, that is a linear cylinder. Okay.
Let's look at some examples of how rotary and linear pneumatic actuators are operated, as there are many different types of each. In the rotary pneumatic actuator category, the vane style and the rack and pinion style are very common. Vane actuators have a cylindrical chamber in which a movable vane is mounted on a shaft. Pneumatic air under pressure applied on one side of the vane causes it to rotate through its stroke. Rack and pinion actuators use a piston attached to rack gear. When pneumatic pressure is applied, the piston and rack move linearly, rotating the pinion gear and drive shaft. In the linear pneumatic actuator category, the spring diaphragm style and the piston style are very common. The piston-style pneumatic actuator utilizes a piston inside a cylinder. The movement of the piston is caused by applying pneumatic pressure, thereby moving the piston upwards. Removing the pneumatic pressure causes the piston to move downward due to the pressure of the spring. This motion is referred to as air to retract. An air to extend motion can also be achieved by rearranging the spring, piston, and pneumatic supply. The spring diaphragm pneumatic actuator is probably the most common actuator used to operate industrial process control valves. So let's have a closer look. The spring diaphragm pneumatic actuator consists of a diaphragm and plate that are connected to an actuator stem. A flexible diaphragm is enclosed in pressure-tight housing. Pneumatic pressure enters this housing, applying pressure to the diaphragm. As the air pressure increases to the diaphragm, the force exerted against the spring increases, causing the actuator stem to move. Reducing the pneumatic pressure will cause the spring to retract the diaphragm. The actuator stem will move a valve in or out of a valve body. In an air-to-open operating condition, the spring forces the valve closed. The air pressure on the diaphragm creates a force that overcomes the force of the spring and opens the valve. By rearranging the spring pneumatic supply, this type of actuator can fail open or fail closed when air pressure is lost. Let's look at a typical spring diaphragm pneumatic actuator connected to a flow control valve in action. A typical pneumatic actuator will stroke a complete 0 to 100% over a pneumatic pressure input range of 3 to 15 psi. The PLC analog output card produces a 4 to 20 milliamp current to move the valve from fully open to fully closed. A signal conditioner called a current to pressure transducer, or I to P, will change the 4 to 20 milliamps into 3 to 15 psi. Okay, let's review what we've discussed. An actuator is a device that makes something move or operate. An actuator receives a source of energy and uses it to move something. The three typical actuator energy sources are pneumatic, electric, and hydraulic. A pneumatic actuator converts energy in the form of compressed air into motion. A pneumatic actuator can move something in a linear motion or a rotary motion. Linear pneumatic actuators include the spring diaphragm style and the piston style. Rotary pneumatic actuators include the rotary vane style and the rack and pinion style. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to Real.
Okay. Now we have this another one actuator. Actually, this is a limited rotary motion type or limited rotary type pneumatic actuator. Okay. So see, from this two port, fluid is going to enter. Okay. And another one, this one again, this is a dual piston type limited rotary actuator. Okay. Or you can call it as a rack and pinion. Okay. So a linear motion is going to convert into rotary. It is called limited rotary action. Okay. That rotary type actuator. So these rotary type air cylinders normally are used for in the application where requiring that cylinder body can be connected to the your rotating member. Okay, to the your rotating member, and while air connections to the your cylinder be in your stationary housing. Okay, such a cylinder, actually this rotary type air cylinder are normally used in the lathe or grinder or the spinning machine. Okay, also we have the another machines with a rotary spindle. Okay, so these are the two types. Now that rotary, that is air motor, that we'll discuss later. Again, we have a small video about this animation of this rotary actuator that we'll discuss.
In pneumatics, cylinders belong to the most important actuators. Controlled by way valves in their direction of movement, they can grip and deposit these workpieces in a controlled manner. Even rotational movement can be executed. It is up to you to consider and choose the appropriate type and size cylinders. Next is an overview of the most common cylinder types, which we will read.
So here you can see how the cylinders are classified into different types. Okay, so if you consider our linear motion pneumatic hydraulic or pneumatic cylinders, then we have this type: single acting, double acting, rodless, double rod. Okay, and in the special we have this telescopic or a tandem cylinder and rotary cylinders. Okay, that is our rotary actuators.
Review and discuss in this video.
The function of cylinders with a piston rod is very simple. A tube, closed on both ends with a cap and heat, has a drive piston. The double-acting cylinder, as shown here, has two inlet ports. The movement of any cylinder is triggered by compressed air. High pressure on one side drives the piston to the other side. Here the piston force can be built up in both sides. That's why this type of cylinder is called a double-acting cylinder. This piston force can be calculated by the law of Pascal. If you have pressure on both sides, the effective piston force is the difference of the forces on the piston and rod side. Normally, double-acting cylinders are actuated by a directional spool valve with 5 ports. Our way valve shown here has 2 switching positions, so you call it 5x2 valve. The way valve directs the compressed air on port 1 to the air ports of the cylinder. Exhaust air from the cylinder is directed to exhaust ports 3 and 5 with these pneumatic mufflers attached. When the piston hits the head or end cap, it creates a hard shock.
Besides the stress on the cylinder components, it is noisy and transmits vibration to the machine. Cushioning is a possibility to decelerate the piston at the vicinity of the caps to prevent these hard shocks. By trapping a certain volume of air in the end position, a braking effect can be generated. With an adjustment screw, you can get the ideal cushioning. Too much cushioning results in slow strokes, and too little cushioning increases the end-of-stroke shock. Especially for sequence controls, you need to detect the end positions of the cylinder. Here, reed sensors are mainly used. To be able to use these sensors, the piston is equipped with a magnet. So when the piston approaches the reed, you get a signal to the control. In summary, double-acting cylinders can have long strokes, up to several meters, with a constant output force through a full stroke. They give the user full control as they can be stopped in any position. But in case of a power loss or pressure failure, you don't have a defined cylinder position. In addition, the air consumption is relatively high as you need compressed air to retract these cylinders. In single-acting cylinders, only one chamber is inflated with compressed air. That's why a piston force is built up in only one direction. The inbuilt spring has the only function to retract the piston automatically when no pressured air is switched to the cylinder. Depending on how this spring acts within the piston, you can distinguish between two different types of single-acting cylinders with different base positions. Base position minus is the common one. As the single-acting cylinder has only one inlet port for the compressed air, you would use a 3x2 directional spool valve. In our example here, we use a spring-loaded directional valve. Due to the inbuilt spring, the piston returns to its base position in case of a power loss. Besides this, the air consumption is about the half of a double-acting cylinder of the same size. However, this inbuilt spring leads also to an inconsistent output force through full stroke and less efficiency due to the opposing spring force. In addition, the stroke is limited by the spring length ability. In general, single-acting cylinders offer a relatively short stroke compared to the double-acting cylinders. Whereas a traditional pneumatic cylinder uses a rod to push or pull the load from the piston, a rodless cylinder moves the load alongside its piston. As a result, you get the same stroke.
Are you getting or not a mechanism or the operation of these cylinders? Please tell me. Please tell me in the chat box. You can write yes, no. Are we getting mechanism, this operation?
Length, but in less space. Same force in both directions, and no rod buckling with high loads and long strokes. Different types of rodless cylinders can be distinguished by the way the piston is connected to the carrier. One principle is the magnetic coupling. Here, the piston and slide are connected together by using permanent magnets. One magnet integrated within the slide, the other one within the piston.
Momentum of that piston. Okay.
In this design, the piston can move in a completely enclosed thin steel pipe. You get a leak-free cylinder with less wear compared to the other types of rodless cylinders and no ingress of contaminants. However, the magnetic coupling is also a force limiter. If the load is too high, you have to worry about decoupling. If you want a rodless cylinder with a high cylinder force, you would choose a slotted rodless cylinder. Here, the piston is mechanically coupled to the carrier. An inner and outer band keeps the air within the barrel of the cylinder. But how so? As the piston drives, the two-band sealing strips open in front and then close behind, regardless of the direction of travel. The seals of the piston inside the cylinder barrel press the inner band tightly against the barrel of the cylinder, preventing air leakage. The outer band is pressed tightly against the outside of the slot of the cylinder barrel with the so-called shoes of the carriage. And it's working! Here you see a band cylinder totally dismounted and fit together again. Inner and outer bands may wear over time as they stretch. As a result, you can get air leaks and loss of air pressure. It is up to the maintenance to replace these bands, especially for expensive cylinders. The last type of rodless cylinder is the so-called cable cylinder. Here, a cable is connected to the piston and drives the carriage through a pulley on each end. This is a very simple design. That's why cable cylinders are relatively inexpensive. But the weak point is the cable itself. Cable wear causes inconsistent positioning, and leaks can occur from stretched cables. You need extra distance? Then take a telescoping cylinder. Also called a multi-stage cylinder, this type of cylinder consists of a series of tubular rods called sleeves. These sleeves sequentially decrease in diameter and are nested inside of each.
Please see how that lifting of one cylinder after another cylinder is happening. Okay, this is called the telescopic cylinder, and this type of the cylinder it is used in truck, dumper and tipper. Okay, that is the main application, telescopic cylinder.
Once pressure is switched to the cylinder, the main sleeve first extends. Once this sleeve is fully extended, the next smaller one begins to extend. Telescoping cylinders provide an exceptional long output stroke from a very compact retracted length. They can be designed as single-acting or double-acting cylinders. Pneumatic rotary cylinder converts compressed air pressure into a rotary motion. One of the most widely used designs is the rack and pinion rotary actuator. A long piston with gear rack teeth meshes with a pinion mounted to an output shaft. The output shaft of this double-acting cylinder rotates counterclockwise by pressurizing the right-hand chamber. Compressed air on the left-hand chamber produces clockwise rotation. Rack and pinion rotary cylinders offer a wide range of torque and rotation. They are mechanically stable and provide radial load support. Vane cylinders have a cylindrical chamber in which a vane is mounted to a central shaft. Air pressure on one side forces the vane to rotate until the end of the stroke is reached. You get vane actuators in two designs. The single vane design has a relatively large rotary motion, up to 280 degrees typically. The double vane type offers a less rotational range, which is limited by half but produces twice the torque. This type of rotary cylinder uses external methods to limit the rotation or to cushion the load. The end position of our cylinder here is detected mechanically. Compared to the rack and pinion cylinder, vane actuators are compact in size and less expensive, but the cycle life is limited by the wear of the vane seals. Also, friction caused by the vane seals and leakage over these vanes result in less efficiency.
Besides a short reaction time, the clean working medium air can even be used in hazardous or explosive areas. Pneumatic cylinders and pneumatic motors cannot overheat due to overload, and maintenance is very simple in most cases. This is why pneumatic cylinders will always have their place aside electric actuators. For more information about pneumatics, please visit our webpage.
Okay. So this is about the pneumatic cylinders. Okay, that is a linear part or air cylinder. Now remaining that air motor that we will see in the next lecture. Okay. So I request all of you please write down your roll number in the chat box after writing your attendance. you can leave this meeting. Thank you. Remaining students, please write down your roll number in the chat box, then leave this meeting. Soham, then Bhaijan, roll number 3568. Please write down your roll number.